Okay, so the last several days we've been working on exponents. We did rational exponents. We reviewed our exponent laws. We solved equations that had exponents in them. And all of that is because we are leading into the exponential parent function. So before we tackle it real quick, let's just talk about all the parent functions that we dealt with. Because this one does have a slight difference. So we have done, the very first one you do, you start it in 9th grade and then we do it in here, is the linear parent function. We all remember that it looks like this, right? And then after the linear parent function, we did the quadratic parent function, which looks like that, except for better, but you know what it looks like, it's a parabola. Then after that one, we did the square root parent function. Anybody remember what that one looks like? Very good. Looks like this. That one does, yeah, looks like that. And then after that one, we did absolute value. What does that one look like? Anybody remember? It's straight on both sides, remember? It's a V. And then absolute, after that, so that's the first four, linear, quadratic, square root, then we did absolute value. Then we did, we just did my least favorite of the whole bunch. We did 1 over x, which is the rational parent function. And it looks like this. Now we're going to do the exponential parent family, or the exponential parent function. The problem with the exponential parent function is it looks like this. Y equals b to the x. And the only reason that's a problem is because b is some number. It's the base, and it has an exponent of x on it. The problem with b is that you cannot plug b into your calculator. It won't work. So you have to use a number. And for some reason, with exponentials, there is not a universally accepted base that we use. Most of the time, it will be a 2. But some textbooks use a 3. Some professors would rather use a 5. Some people use a 10. So there's no universal parent function base for this one. But for the purposes of just seeing what it looks like, I'm going to use a 2 as the base and plug it in the calculator so that you can see. 2 raised to the x power looks like that. And it's an exponential.
And the 2 still is...
2 is just... 2, well, actually no, and we'll get to that part in the next couple of days about what the value does. And that's a good question. That 2 is not a vertical stretch or compression or anything like that. It is the actual base of the parent function. And that is what makes this parent function different. It's not the only one, but it's the first one that you've encountered that actually has a number in it. If you look at all the others that we've done, it's all just x. X squared, square root of x, absolute value of x, and even the rational, it has a 1, but that 1 is really just a placeholder so that the x is in the basement. So it's the first parent function we've had that has an actual number that goes somewhere, and that's why they use a b. The b is a constant, and it could be any constant except 1. It can't be 1. And we'll talk about why it can't be 1 in just a minute, and you'll see. Okay, so now let's get out, are you able at the table? And you can see at the top, it says the basic form of the exponential function is y equals a times b to the x power, where both a and b are constants, some numbers. What effect do a and b have in the table represented in the functions below? Find out by using your calculator to complete each table. So right here is the function that you're going to put in your calculator. So plug that in and fill in the table. So I'm going to give you a minute. Go ahead and do 1, 2, and 3 and then stop. And we're going to talk about them for a second. 1, what's your A value?
3,
And your B value?
2.
And when you plug it in the table, going right down the table, you should have 3, 6, 12, 24, 48. Okay, so then it asks me what the ratio is. What do you think they want to know? Simplify which part? I mean, it is, yes, but
X and Y.
kind of. Why do you think they have it written outside the table like this? What do they think that they're trying to figure out? In between. So how am I going from here to here? What are you doing each time to move down the table?
Multiply by B.
Multiplying by, in this case, 2, which happens to be your B value. So if I look at number 2, and my A value is 2, my B value is 3. So I filled in my table, and this time I'm multiplying to go down the table, I'm multiplying by 3. And then here's this one, your A value, there wasn't one. So if there's not one, it's understood to be a 1. The base is 6. Now how did I know that the 6 was the base and not the A value?
Since B is error function is B of X.
Right, because it's B of X. It's what the X is attached to, so it has to be the B. So I filled this in. That meant I was moving down the table by multiplying by, oop, I messed up, because that should be 36 right there. I didn't plug it in, I was just doing it in my head. This should be 36, this should be 216,
So nice.
so on and so forth.
All means square.
Okay, so now, let me ask you a question, because 3 times 2 is 6. So that would be 6 to the x, right? And this is 2 times 3, which is 6, and that would be 6 to the x. And that is 6 to the x. So why did these not generate the exact same table?
Because the 3 already had. Well, I wanted to, the 2 has the X. You're supposed to multiply the A by the B. Like your B.
You're right. I think you both know. I think you both know what you mean. The exponent has to happen first, right? Because please excuse my ignorance, Sally says it does. Exponents have to happen before multiplication. So I have to do the B part before I can multiply by A. So in this case, I do 2 to the 0. Anything to the 0 power is 1. Then I multiply by 3. 2 to the 1, that's 2 times 3. 2 squared would be 4. 4 times 3 is 12. So you have to do the exponent part first. That's why, even though these look like they might be the same, they're not. Okay, so now on this one, let's go ahead and fill in our A, our B, and our ratio. So my A is 8. My B value is 0.5. I'll plug it in my calculator. Okay, now before I write the ratio down, what do you notice about the Y column here? What's happening now to the numbers?
Multiply by half or split in half.
Right, it's actually, they're getting smaller, right? And yes, it's both things. It's dividing by 2. However, when we write this, anytime you write a ratio, they want to know what you multiply by. So yes, it's dividing by 2, but you're multiplying by a half. So when we write the ratio, we want to write it as multiplying by 0.5. Multiply by 0.5, or multiplying by a half. Either one's fine. It doesn't matter. So on 5, my A value is 100. My B value is 0.5. Before I plug it in my calculator and look at it, what can you tell me about my Y values? How are they going to be moving? What do you think is going to happen to them? They should be split in half or getting smaller each time. again, I'm multiplying by a half. So on number 6, my A value is 200, my B value is 0.8. Okay, now this one, it's not as easy to see. All of these others were super easy to see. From 8 to 4 is clearly half. 4 to 2 is a half. 100 to 50 is a half. 50 to 25 is a half. So that one's pretty clear and easy to see. I can't see what this is.
Right, 0.8.
It's 0.8. How do you know?
So what your B value is?
Because it's what your B value is. It's always what your B value is. So I'm going to put 0.8. I'm multiplying by 0.8 each time. Now, what if I didn't have the function? If they hadn't given me this to put in my calculator, what if all they had given me was the table, which they're about to on the back. They're going to give you the table and you're supposed to come up with a function. How can you find the ratio if you're unsure? Look at these and figure out how can you get a half out of this table?
Plug in the edge for the...
What do you do?
Or are you trying to find the ratio?
Yeah, I'm trying to find the ratio if I didn't know the function. If all I had was the table. How could you find the ratio? Look at some of the ones at the top. What if I didn't know? What if I didn't know and I wasn't given, well, let's do these two. Let's say all you were given is 1 and 6 and 2 and 12.
Divide.
You divide. You just divide. So in this case though, you divide 12 by 6. Since 12 divided by 6 would give you 2, not 6 divided by 12 because that gives you a half. So it's always the second number divided by the first, or the fourth number divided by the third. It's always the bigger number divided. So I could do 50 divided by 100. That's what gives you a half. So in this case, 160 divided by 200 would give you 0.8. So that's how you find it. That's why it's called a ratio.
But do they have to be next to each other? You can't do like 0 and 4.
Yeah, no. They do have, yes, that's a good question. They do have to be next to each other. They have to be one step apart. Okay, so on the back, oh wait, I guess we should answer these questions. Where does the A value show up on the table?
Y-intercept.
It's always the y-intercept, so it's with 0. It's the y-intercept. And what effect does the B value have on the table? Of course, we've already talked about it a billion times now. It's the ratio. Alright, so on the back, the A value also has, when we deal with exponentials, besides the fact that graphically it's the y-intercept, it has a special name. It is called the initial value. And that's because we are going to do lots of very useful and practical word problems with exponentials. Next to linear, they may be the most commonly used mathematical problems, and they will. I can almost guarantee you 100% that you will use them in your life after you get out of high school, even if you do not do anything with math, because they really are that useful. So it's called the initial value when you're talking about word problems. Of course, we just said it's the y-intercept, that A value. The B value is the ratio. Now, y values increase when, well, let's look at it. If we look over here on this page, at the top two, my y values are increasing. 3, 6, 12, 24, these are getting bigger. 2, 6, 18, these are getting bigger. So they're increasing. And then on these, 5 and 6, my y values are decreasing. They're getting smaller. What's the difference? What's causing that?
The ratio is below 1.
The ratio is below 1. So, in order for the y values to increase, your b value is greater than 1. 2, 6, 5, anything like that's going to make it increase. In order for it to decrease, it has to be between 0 and 1. Your b value cannot be negative. And I'm going to show you in a minute why it can't be negative. Okay, so now we're going to do the reverse. They've given you the table. You come up with your a and your b value and your ratio. I'll give you a minute to do 4 problems. Okay. I got my initial value is 5 and my ratio is 4. That one was easy. On number 8, your initial value is 2 and your ratio is 9. 9 and 10 weren't quite as easy because you couldn't just look at it and tell, so I actually had to divide. So on number 9, I got my initial value is 16, that you get straight from the table. And my ratio, I divided 24 by 16 and got 1.5. And then on 10, my initial value is 500, got that right off the table, and I divided 200 by 500, got 0.4. Is everybody okay? Any questions? This is easy, right? Okay, so now let's look over here at the think about it, and let's put these in our table and see what happens. So on this first one, it's saying 4 times 1 to the x. So go ahead and put 4 times 1 to the x in your calculator. And notice what happens. Your y values are just straight 4s. That's because no matter what we raise 1 to the 1 is 1, and multiply that by 4 is 4. 1 to the 2 is 1, multiply that by 4 is 4. 1 to the 3 is 1. So 1 cannot be our base because 1 as a base never changes. So that one won't work. So now let's try 4 to the negative 2. Now put it in parentheses, because your calculator, you have to identify negative numbers by putting them in parentheses. Now when you hit graph, if you hit graph, nothing shows up. So go to the table and look at the table. What do you notice about the table? It is sort of all over the place. It goes back and forth.
And
it alternates between negative and positive. And so it can't work. Now, this calculator will sort of graph it, and as a matter of fact, let me show you. It's still graphing it. If I leave it, it'll keep going. It should anyway, in just a minute. But you can see the little dots. There it goes. It's jumping back and forth, because every time you change an exponent from odd to even, if the base is negative, it changes your y value, negative, positive, and it does it a million, just every little bitty space, which is where this comes from. Well, obviously, it's jumping like that. That's not going to work. That can't work as a function. So you can't have your base be negative. So that's what this part is all about. So now you know your base can't be negative. We know where to find our initial value. We know how to find our ratio, which is how we move down the table. So we'll talk more about transforming them later, but now we actually want to look at a word problem so that the whole concept of the initial value makes sense. Keep your able with the table, because I'm pretty sure at some point I'm going to have to say, go back and find the page. Are you able with the table? All right, so money. College loan. To help you with the cost of tuition, room, and board, you take out a $20,000 loan for college. You do not have to make any payments on the loan until you leave school. That is true. When you take out a loan for college, you do not have to pay until you're no longer in school. Whether or not that's a good idea, you'll just have to decide for yourself. However, the loan amount accumulates interest at the rate of 12% annually. Now, that's a lot. That's a very high percentage for a student loan. As a matter of fact, I think they're not even allowed to charge you that much anymore, but at one time they did, and they maybe could. So, to determine how much you will owe after X years of college, complete the table and the graph and round your answers to the nearest whole dollar. So, we have our initial value, $20,000. That's on our table. So M of X, I know my initial value is 20,000. Now it makes sense why it's called your initial value, right? Because that's the initial amount that you borrowed. Now what I have to figure out is, what is my ratio? So how much am I going to be charged each year? You're going to be charged 12%, right, of what you owe? Because it says 12% annually. But be careful when you have ratios like this, these money problems, because you don't just have to pay back 12%. You have to pay back the initial 100% that you borrowed. So instead of just 0.12 inside this parentheses, it's going to be 1.12. Does everybody understand why? Raised to the x power. Because I have to pay all of it back. I have to pay back the $20,000. That's the one in front of the decimal represents the 20,000 I have to pay back. And the 0.12 represents the 12%. Okay, so we're going to plug that in our calculator and get ourselves a table. after graduating from, so mine kind of looks like that, it's not a great graph, but, suppose after graduating college I enter law school, and it's gonna take me 8 years, so at 8 years, I would have $49,519. Wow. Okay, before I go any further, as law school, you have not borrowed another dime. You borrowed $20,000 and you now have to pay back $49,519. It's a little scary. 12 years, if I decide to go to medical school after undergraduate instead of going to law school, it's going to cost me $77,920 to pay back the $20,000 that I borrowed. Okay, so now, what is the domain and range of the problem situation? So my domain is years. So my domain would be 0 to, I guess, infinity. I mean, you could just take forever to pay this thing off. Your range, 20,000, because that's your initial value. That's how much you borrowed in the first place. 20,000 to also infinity. However long it takes you to pay this thing off, it keeps accumulating interest. So it's just going to get more and more and more. Now, just so you're aware, this is the way that loans are calculated, which is why I said I can almost say with 100% assurance, you will deal with this kind of problem in your life. Whether or not you go on and do anything with math, it won't matter, because this is how loans are calculated. And if you ever take out a loan for anything, for your car, for school, for a house, this is how they're calculated. Okay, so now we're going to do a car depreciation. So this is also how things depreciate. I know you guys have all heard about cars depreciating in value. The minute you drive it off the lot, it is not worth what you just paid for it. That's just the way cars work. Now, homes, houses, they appreciate in value. They're worth more as time goes by. Cars, not the case. As soon as you drive it off the lot, it depreciates. And depreciation is calculated with an exponential function. So, as a graduation gift, your grandparents buy you a shiny new car worth $20,000. Our initial value is $20,000, just like it was with the other column. However, due to wear and tear, the car loses 20% of its value every year. So to determine the value of the car after X years, complete the table and graph. So our initial value, or our A, is 20,000 again. Inside of this needs to be our ratio, or how we're moving down the table. Now you have to be careful on this one, because they told me how much the car loses in value. It loses 20%. But then what the question is asking me is, what is the car's value? Not how much does it lose, but what is the value? So if it loses 20%, what is the value that it has? Do you understand what I'm saying?
After a number of years?
Or just in general, if I lose 20%, what value is remaining in the car? Do y'all understand what I'm asking?
It depends on how many years it is.
Well, if it started out at a value of 100%, yes, it does. But let's just say year one. If it starts out at 100% of value and it loses 20% of its value, what value is remaining? 80. So when it's asking this column, it wants to know what value is remaining. So the ratio that I'm putting in here is 80%, not the 20. Do you understand what I'm saying? Because it's asking for the car value. It's not asking you how much does it depreciate each year. It's asking you really how much is it worth. And every year is worth 80% of what it was the year before. So it's going to be 80% to the x, or 0.80 to the x. So now I'm going to put that in the calculator. Alright, so in year one, my $20,000 car is worth $16,000. In year two, it's worth $12,800. looks kind of like that. So then it asks me on the first bullet, how much would the car be worth in 10 years? $2,147.50. 25 years. Wow. It's worth $75. $75.56 in 25 years. Okay, according to this function rule, this one that we created, that says every year it's worth 80% of what it was the year before. When is it going to be worth nothing?
Never.
Never. It's never worth nothing. Mathematically, it's never worth nothing because there's an asymptote in exponentials. There's an asymptote at 0, and it's going to get as close to 0 as it can get and never touch it. That's mathematically why it's never going to be nothing. But realistically, why will it never be nothing?
You can scrap it.
Because you can always scrap it.
I don't even-
There's always something on it that's worth something. As a matter of fact, I don't know that it would ever really only be worth 75. There's probably enough scrap in it for it to be worth more than that. But if you follow the function, they're saying 75. Okay, the domain and range of this problem situation, this time domain is years again. Starts at 0. It could go to infinity. Long after we're gone, that pieces of that car could still remain, I guess. And in this case, my initial value, remember you got to list it smallest to largest. It's going to be 0, not included, to 20,000. And that 20,000 is included because that's how much it was worth at the beginning. It won't ever be worth more than that. And it could potentially go all the way down to 0. Now here's where, this is a kind of an interesting problem to look at because here's where people get in trouble. You buy a car for $20,000, but you take out a loan at 12%. If you do that, in year 1, your car is now only worth 16, and you owe $22,400. So you now owe more than what the car is worth. That's called being upside down to the loan. Don't do that. Learn now. That's how your math teacher in Algebra 2 told you, don't do that. Cars depreciate, so